Oh yeah, so I discovered this site on the internet yesterday just to light up your day. Some dancing, what are they called? Dancing lizards. And it has like a scroll effect when you scroll further. Yeah, so that was a little fun. Yeah. And you can find it on vercel.vercel.vercel.app. Yeah. Cool, let's get started. Cool. So while I was preparing for this talk, the title somewhat changed as I was preparing. So today we'll be talking about Fullstack Type Safety, the Remix edition. How many of you have heard of the framework called Remix? Okay, so we have a lot to learn. So who am I? My name is Alex. I consider myself a Markdown and MDX ninja at Prisma because those are the technologies that I get to play around with most of the time. However, but all jokes aside, I'm a developer advocate, and in case you have any questions about Prisma, complaints, I'm your person, and then we'll get it to product and hopefully get the feature shipped at some point. And in case you'd like to talk to me, whether it's at the meetup or after the meetup, you can find me on Twitter still at Ruheni_Alex. Yes. Not yet. So what are we going to talk about today? So the talk was divided into 4 sections, and in the first part we'll reintroduce the concept of end-to-end type safety and take a look at the sample application or the 3-tier architecture and parts of the application where things could go wrong. And this is the point in time where we'll get to wear our detective's hat and kind of take a look at the application. And then in the second segment, we will use some of the TypeScript utilities and patterns that are already existing and solve the issues that we found in the first segment. And then in the third segment, I'll take part in an extreme sport that I like to call live coding. And let's see how high I can get my pulse. So yeah. And then finally, we'll conclude, and then in case you have any questions, feel free to ask them at that point. So let's get started. So what is end-to-end type safety, and what part of the application or where could things go wrong? Well, end-to-end type safety is the idea that your application is fully typed from your database all the way to your API and backend, and then all the way to your frontend. And this means that a change in one piece of your application, for example, the database schema, will be able to cascade the changes all the way back to your backend or Node.js server, and then all the way to your frontend. And this should happen before you, ship your applications to even staging or push a commit. And so the parts where sort of data is exchanged, I'd like to call them boundaries. For example, when you make a submission to the API, from the front end and to the API, I guess. That's an example of a boundary. So sadly, I don't have pretty images like Emma did. So I swear they looked better on Excalibur, but this is what they end up looking like. And this is your typical 3-tier architecture application. So over here we have a user, which could be me. And then the typical flow is open up a website like vercel.vercel.vercel.app. And then if I have anything to do there, I could, for example, request for posts, for example, if it's a blog. And then this request would perhaps be sent to an API or a backend. And then the backend would probably communicate to the database. And then this, whatever we get from the database will be propagated all the way back to the front end. But there are some moving parts where things could go wrong. For example, when a user is creating a blog post and you need to validate the data that's moving from the front end to the back end is of the correct shape. Another point of failure is the data access between the data access layer and the database when you're trying to submit data or send data to the backend database or retrieve, but you're not quite sure of the types that it is. I mean, the shape is okay, but the types are saying something else. And the other kind of point of failure is when you're trying to make network requests to your application and you're using fetch and tells you it's a promise and it's any, sadly. Yeah. So let's take a look at some kind of code snippets. And I wish I knew sli.dev. Yes, I pasted in some code snippets. And this is an example of form submission with Remix, which I'll dive into just a bit. And when you're when you're extracting the form values from the form data, you get a type of form data here, which is not quite helpful if you have 10 different properties on your form, like, for example, title, content, and etc. So, this is one point of failure where we could, mess up in our application with our types. And another piece where we could go wrong is when you're trying to make network requests. And this is a fairly simple fetch request to an API where we're trying to get a list of all posts. However, when you hover on posts or when you look at the posts, it's a promise, which is any. And while you might argue that you can just define a type for it, the problem comes in when the backend changes and they decide to rename content to content to body, and then you're left with an undefined. So you're kind of lying both to yourself and to the TypeScript compiler, so the application somewhat breaks. Another part that I've highlighted where things could go wrong is on the database side, where in this case I'm using Nex, but you could choose to use raw SQL because you prefer performance, but not Prisma, sadly. And in this case, we have a feed, and it's making a request. We're trying to query all the posts from our database, and we're selecting only the ID and the title fields. This is also using TypeScript, by the way. So when you try to get the types off of the feed function here, sadly, you'll get a promise that's of any, and yes, you can type it, but the problem is you kind of have to keep in sync the structure of your data in your database with TypeScript types. So with all these kind of challenges highlighted, how can we solve it? And what are the different patterns that we could adopt in TypeScript? The first one is using type guards. And type guards are functions that allow you to make assertions that specify that and help you ensure that the shape of your data is exactly what you expect it to be. And Fabian was here the previous meetup, and Benny, returning a speaker, gave a really great talk about type guards, and I'll link it in the end to a QR code in case you'd like to know, follow up. But type guards allow you to infer types across the different boundaries. For example, when you're validating the form data when a user submits the form. Some of the useful utilities that TypeScript provides are the type of keyword, the instance of, and the in. Type of allows you to assert that an object is of a specific type or shape. An instance of helps you assert that an object is of a particular class, I believe. And then in just helps you ensure that you can check that a property exists inside a given object. So this is an example use case where we're using a type guard, and we're trying to assert that the value of title and content is of type string. And with the type of keyword, the types are narrowed down from a form data value all the way down to a title. And this is the value that we get from using a type guard. You're able to move from a wide type and narrow it down to just one specific or type that you would wish. A utility library that I use a lot that's called Zod, and I love it. I have to say.
Really enjoyed.
Same.
Well, yeah.
I'm here to talk all about it. I'm joking.
Just a tiny bit smaller in terms of kilobytes.
Yes. So you get sort of the value in twofold. And the first one is that you're able to validate the structure of your data. It's similar to Joy and Yap, I believe. And
Superstruct.
Yes, and you're also able to kind of infer types once you've sort of parsed the shape of your data. So in this case, I'm retrieving the form data, and then I'm getting all the properties and the values, and then I'm parsing it here and confirming that there's a success. And if you were to use Zod and then hover on the data type, you'll get a narrowed down type, which is what we'd like. And the type comes from the schema that we've defined over here. I'm probably not going to do it a lot of justice, but I guarantee you should check out Zod if you can, definitely. The other pattern that we could use is using type generators. And this is not a new concept because there are tools that have existed that already do this. But the idea is that you use other tools, or how I like to say it, leave it to the smarter people, for example. So they've already figured out they have better or deeper knowledge in a topic, and the tools essentially generate types for you, type definitions that you can use in the rest of your application. A good example, not a generator per se, but is the Open API specification that if you're using REST APIs, it specifies how you should kind of structure the data. And then people have built a ton of libraries that allow you to define, to generate type definitions based off of the schema. Another popular tool is the GraphQL code generator, which you'd give it, for example, just a GraphQL schema, and then based off of that, it will generate for you the type definitions for the either your server or on your client. And then finally, which I get to talk about a lot, is Prisma, which allows you to define the structure of your database schema in a model, and then in the event when you apply the change to your database, it generates the type definitions for you automatically. And this is just scratching the surface of how much it could do. And the other bits of stuff is like specifying narrowing down types whenever you're selecting specific fields when you're querying a table. So, time to get my heart rate up. So I built a very, very pretty application. And I say it's pretty because this is what it looks like. It's a fairly simple application. This is the homepage, and what it's essentially doing is querying the database for all the posts in our table. And if you'd like to create a new post, you can click on the Create Post button, and then we get a form title, third post TS meetup, and I'll just copy and paste, or just content, and then when I click submit, I've created the post. Then when I navigate back to the home page, the post is right here. And I can just click on any. It's very pretty, I know, innovative. Yeah. So let's take a look at it. So for this sample application, I built it using Remix. And I'd like to refer Remix, don't quote me on this, but it could be the minimalist's type-safe stack, because you don't have to do much to get type safety going along. It's a modern web framework built on Remix. Sadly, yeah, it's Remix, not Astro yet. And with Remix, it takes you back to the web fundamentals, where we kind of just take out all the abstractions that we've created over the years when we invented the frameworks, and just allows you to focus on the core basics on how the web was supposed to function. And I love it. It's another tool besides Zod that I also love. So let's take a tour of the application. So for the database, I'm using Prisma, and I'm using SQLite for the database. And I have a model with 5 fields: the ID, title, content, published at, and created at. Which in the front end, I have 3 routes. There's the homepage, which is the index page here. And I should highlight that Remix provides something called a loader. And a loader is a function that runs on the server side to sort of fetch data. And in this case, we're using Prisma to query the data here. And we can see that it's completely type safe. It's exactly what we've selected. And if I take out a field over there, we can see that it's already narrowed down to excluding the created at field. And then when this runs on the backend, on the server, you can use the useLoaderData hook, which they also provide, that allows you to access the data that's returned from a loader function. And I'm also using a type guard here to kind of specify the type of the data that should be returned. And in this case, we are returning posts here, which should be an array, and we can access it over here. And then the next part of the application is the part, the form, the beautiful form for creating the posts. So I defined my post schema over here, and it has two fields, a title and a content, which is also specified inside the view. Unfortunately, I didn't get a lot of type safety when specifying the fields, so in case I rename the title here, I'd probably spend a couple hours just trying to figure out why I went wrong. But yeah, it provides something called an action function, which handles like form submissions or submitting data to a server. And again, this also runs on the server. And also one beautiful thing about Remix is that when you use loaders and functions, they always run on the server, so you can always disable JavaScript and your app will still be able to function. And yeah, and finally we have the ID route with a single loader. Sadly, I'm casting the ID here from the request parameter, and then performing some type narrowing here. So if we hover on the post here, we get a type of post or a null. And then we are performing some type checking, which narrows down the type here to just a post. So in the event the post is not found, we'll return a 4.4. And if we try that out with 1, 2, 3, get a 4.4. And yeah. So now that I've walked you through the beautiful app that I built and the code base, which is fairly simple, I'm going to introduce sort of two breaking changes. And the first one is on the index page. I am going to remove, it's not necessarily breaking, but let's take out the content field. So we can already see that the TypeScript compiler, or it's yelling at us that the field is not defined. So this is the value of the type safety here, that even though they are across different boundaries, which is after fetching data, we are still able to catch such type errors pretty fast. So I'll go ahead and return that, and then make another slightly bigger breaking change, and that's renaming the what is it? I'm not using the field anywhere yet. Oh yeah, inside the schema, I'll go ahead and rename content to body. Then I'm going to apply this to the database. How many servers are running? Anywho, I'll just close one. Yeah, I'll restart this one. And then I will run a migration, and then I'll call this rename content field. Then this it's a sort of a breaking change, so I'll sadly lose all the data that I have, so I'll accept the change. And the schema is generated, and already we can see there are two problems in our application. And the first one is on the index page, where the content field is not available. So I'll have to rename that to body and set it to true. Well, add a comma there. And then back here, I'll also rename this to body. Then yeah, and that was it. It felt a little too simple. Yeah, so that's the beauty of type safety. And again, I didn't have to get a lot up and running to get this functional. So let's go back to the slides. Yes.
Don't you need to modify the form?
Oh yeah, I do have to modify the form. So that's the part that sadly we don't catch. So let's go to new. We renamed content. So content to body. Then, yep, this is also missing. So content, that was renamed. So I'll have to rename this back to body. And then I'll have to update the ID value from content to body. The app should be functional. Fingers crossed. Oh, it's not. The content does not exist. So yeah, probably. Thanks for catching that. Yeah, that's how it's live coding. We all learn. So, sorry?
Always a surprise.
Always a surprise. Yeah, and it works. I'm surprised that the data is still here. Something must be wrong. Anyway. Cool, so let's go back to the slides. So in conclusion, I walked you through what the application data flow looks like and what ideally end-to-end type safety should be. And then we also explored the different patterns and concepts that we could use to adopt type safety, which is using type guards and type generators. And then finally, I walked you through the demo that we all fixed. Thank you all for all the help, by the way. And that's it. So if you'd like a link to all the resources that I covered, you can scan the QR code. There are about 10 links to Benny's talk and a few others, the remix docs. And yeah, you'll see it. So thank you. And in case you have any questions, feel free to ask. Yeah.
I could just...
Yes.
It's more like just noting a couple of things. There's also an interesting library that popped up recently for me. It was called TRPC, which does the type safe. Well, it's not type safe. It just tells you that it can be safe unless you do something stupid. And another thing is that in good old times of C# there was a code-first approach where you first design something in your code, and because this compile time types reflection, it can build you a database according to the types and not the other way around, which I always felt like is something I wanted for GraphQL, where I just build my endpoints and then it just figures out what kind of GraphQL schema it allows. But it can't do it without some compiler kind of a thing. So there's no runtime thing like you would do in other languages like C#. Oh yeah, but that's the thing. And yeah, Zod is absolutely perfect. I just discovered like a month ago or two, and I just rewrote everything that I had. But just to note that TypeScript, the latest version allows it to narrow types down based on in. So if you say if the property in the object, it suddenly says, oh, there's a new property on the object, and it wouldn't do that just a month ago. So it's pretty nice.
Today I learned. Yeah.
Cool.
Cool. And you can, of course, achieve end-to-end type safety with other tools, and TRPC is especially one of the most popular ones, and using the T3 stack as well. And it's pretty good. That's all I can say.
Okay. Cool. There's also a library called Superscript, but it just does not look as nice when you code it because it's some kind of more functional approach. But a functional approach doesn't work well with JavaScript. It's just like doesn't look good. So yeah.
Cool. Thank you.
Yeah. Cool. Thanks.
Thank you.
Any other questions, comments?
Remarks?
Thank you. It was wonderful. You showed that Remix is almost there in terms of type safety, but there's things missing, like, for example, type safety with forms. What do you feel is the missing piece? What do we need to achieve full type safety? How would you design a framework differently?
I wouldn't build another framework, that's for sure. We have enough. There is certainly, I think there's a forms library that's kind of in beta for Remix that someone's working on it. There's also another one called RoutesGen, I believe, Remix RoutesGen, that allows you to also kind of generate routes on the fly. It's a type generator for routes. I haven't had the chance to try them out, but hopefully I can try them and then come present again. Yeah.
Thank you.
Cool. Thank you. Awesome. If there are no further questions, I'll leave the floor back to Natalia.